Welcome to my YouTube channel. Today I'm talking about null and alternative hypothesis. So, this is kind of like in a courtroom where you assume a defendant is not guilty until proven otherwise. In hypothesis testing, we assume the data is consistent with the null hypothesis until we have evidence that it's not. So, we often set the null hypothesis to be no difference between groups, or the data has some mean or something to that effect. No difference, or the data in the case of a one sample t-test is equal to some value, which would also be saying that the data minus that value is equal to 0. If we're talking about you could have moved the numbers around in your hypothesis, and it will be that type of deal. Okay, so we say no effect. That's the null hypothesis most often. That's not the null hypothesis you have to use. You could make the null hypothesis anything you wanted. I wouldn't. Most people would not go along with that idea. They would seriously question you. But you could make the null hypothesis that the groups are different. But that's not what anyone ever does. If you are looking at a test between two groups, your null hypothesis is that they are not different. And in the alternative hypothesis, you're going to say some difference. So, in your two-tailed test, the population parameter is not equal to a certain value. The mean is not equal to 1. And you can often do left and right-tailed tests, or one-tailed tests. And that is generally disfavored in science. One-tailed tests are more likely to be significant. They are more likely to find a result in a particular direction. And the concern is that if you do a one-tailed test, it's too likely to find positive results. And we favor a two-tailed test. And a more cynical person might even believe that you did a two-tailed test and it was not significant, and then you did a one-tailed test and it was significant and you only reported that. Should one-tailed tests be allowed? Yes. And are they allowed some places? Yes. But two-tailed tests are significantly more favored. And you may very well be met with questioning if you do a one-tailed test. But if you do a one-tailed test, the 8O and 8A, the null and alternative hypothesis, are slightly different. Let's say we assume the effect to be positive, like the treatment group will have higher test scores. The null hypothesis will be that the difference is less than or equal to 0, and then the alternative would be greater than 0. Or going the other way, if we expected worse test scores, the null hypothesis would be greater than or equal to 0, and then the alternative would be less than 0. Okay? So the hypotheses need to be mutually exclusive and exhaustive. So what I mean by that, mutually exclusive is any one value cannot be both. It cannot be in the null hypothesis and the alternative hypothesis. So for example, 0. 0 cannot be a possibility in both hypotheses. So that's why I said less than or equal to in each cell, and I did not say equal to in the alternative. Because if we had a value of 0, we did not want that possibility to be in both. Exhaustive means we can't have a value that doesn't have its place. So the null hypothesis cannot be 0 and the alternative be 1. That would be wrong. You would never know what to do with a negative 1. You would never know what to do with any value that wasn't 0, 1. And that's not even something I'd know how to work with. So the null hypothesis and the alternative hypothesis need to include any possible result. Okay? So briefly, I'm going to talk about the process here. So state the null and alternative hypothesis. Choose a significance level, which is almost certainly going to be 0.05, unless you have a good reason for it not to be. You perform the test. You get the p-value from the test. You most likely use statistical software, so that would simply be given to you. If not, you have to go look it up on a table and find the corresponding probability. And then if the p-value is less than the significance level, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. So, example, in a two-tailed test, the population mean weight is exactly equal to 70 kilograms. And an alternative is that it's not equal to 70 kilograms. And we're not saying if it's less than or greater than, we're just saying it's not 70. And I feel like there was another point. Yes. So our hypothesis is not that the sample mean our hypothesis is not that the sample mean is any value. We know the sample mean. That's not interesting. What we're trying to get at is the population mean. So that's why this is written with a mu and not an x bar. Because we don't actually care about the sample. We know what it is. It's whatever x bar you calculated. The whole point of the hypothesis test is to get at the population mean. The population value that we could not observe. Okay. So that's the end of the video. Thank you for watching.